everyone, welcome to the Broken Science Medical Society webinars. Today we're excited to welcome Dr. Richard Feinman, who will guide us through the essential skill of critically evaluating research, a key to distinguishing reliable science from flawed models.
Well, I've been a critic of the nutrition literature for a while. The literature is affected by studies with small sample sizes, tiny effects, expression retrofitting hypotheses to fit their data. The problem is statistics altogether. And statistics is a mathematical science, and you have to make a certain number of assumptions. And what I want to emphasize is a particular philosophical point of view, which is the idea in medical nutrition and statistics is that there's a real answer out there, and all you have to do is manipulate your data and show that you can, as they put it, exclude the null hypothesis. Points that I would make about what's wrong with the nutritional literature is that mathematical and formal manipulations are done, and if they come out the way you expected, that's interpreted as having accomplished something. And that's where you would get into trouble. We talk about this stuff all the time, but if you step back and ask, what is it about Hill's criteria? They are as expected. You expect dose response curves, you expect specificity, but what is he really asking? He's saying, are we going with this major idea, major approach to analyzing scientific studies, and it doesn't give us the answer? We have to ask, what other feature do we need that would give us the answer? And we want to know, what is the effect of the intervention? What I'm going to emphasize today is the idea that red meat is a risk for diabetes. Most recently, they've started emphasizing red meat, and that's wrong. There's nothing in diabetes that would suggest to you that red meat, or any meat for that matter, it's really come down to emphasizing protein. Idea that a high protein diet is a risk for type 2 diabetes is wrong. It's very hard to make big judgments in nutrition. Relative risk is simply the risk of the experimental subjects versus the risk to the controls. You have to know the absolute value. The fact that Alice has 30% more money than Bob does not matter. She may be on welfare. They may both be on welfare. You have to know the absolute value. The bottom line here, which is that when you look through the literature, you get these three different things. They're slightly different, but you're usually talking about relatively low incidence, and then you can use them interchangeably. Turns out to be a pretty good approximation. Joke about a woman who claims the guy across the street is exposing himself, and she calls the police, and the cop comes and he looks at the window across the way, and he says, "Lady, that window is too high. I can't see anything." And she says, "Sure, where you're standing, but come over here, stand on this chair, and you'll see what I'm talking about." So if you have to do that much work to get the relative risk come out right, that's a problem.
If you just count up the number of p-values that they reported in that study, it must be hundreds. And each one of those p-values is a hypothesis. And so they're asking hundreds of questions. It's like they're taking so many shots on goal. And I can't even imagine epidemiology. I wish they wore a camera on their forehead, and I could look at all the relationships that they look for before they even publish these studies, so that they're looking for all these relationships, and they report the ones that they find quote unquote significant. But that's on the backdrop of all of, I guess you call it p-hacking, or they call phishing, et cetera, where they look for an association, yet, in order to find it, they have to look about 1,000 times.
You don't see the data. What you're seeing is the averages of the data. And if there's a single statistical error in medical nutrition, it's that nobody gets an average degree of diabetes. You're hoping that the big picture will tell you what the drift is. And we published this in a comparison of a low-fat diet, a low-carbohydrate diet from Jeff Bolick's. And you look at it and you can see what's going on.
Yeah, oftentimes I find with these epidemiological studies, I will give the New England Journal of Medicine credit that I think they do it as a practice, that anytime they show one of those figures where you try to get your laser pointer in between the relative risk, they always scale it. They'll have a scale and they'll show you the absolute risk. So they'll show you the absolute number of events.
No, that's very good, yeah.
But when I ask them, I'll email them and I'll ask them for the raw data, how many actual events were in each group? And they'll say, we don't provide that because basically it confuses people and the media misinterpret. They'll misinterpret the study if they show the actual number of events in the study because they do all of this quote unquote adjusting or controlling. But you think, how much should I trust a study that won't actually show the actual data? Once randomized, always analyzed.
This is a study clearly very carefully done. What you can see is the dramatic difference between the control diet, which again was a low-fat diet and was giving greater cardiovascular disease. The reason I went through the formalism on these parameters is that the hazard ratio, again, like the odds ratio, is about 0.7. That's not very much. Remember that the two things would be the same if they were 1. The calculation I did to show you what the odds ratio was is you can take the odds ratio and work backwards. It shows you that the data points from the different studies on both sides of this, which is telling you the key thing, if you try to reduce your saturated fat and put it in carbohydrate, you're not getting anywhere. In other words, if you don't get sick with red meat, remember, it's an association now. You're studying sick and red meat. You get sick with no red meat. Maybe not as much, but if it's 50-50, you're still at risk. So do you want to change your diet? Do you want to take a pill? First line of advice in analyzing scientific papers is look for the pictures. The author can't show you a clear graphic demonstration of what's going on. So if you're in a high red meat group, what's the probability that you'll actually have diabetes? Diabetes is a serious disease, and you might want to know what you'd actually gain by reducing red meat. The real story on red meat is barely discussed because it's about the real nutrition, which is biochemistry. What is the evidence that a vegetarian diet is healthy and protective? Well, there are lots of people who do it all the time. They live to an old age, and some of them are in the Olympics. That's how you know they work. And the same thing is true for low-carb diets. That's how you know there are different choices.
If you need statistics to tell you that something is, that there's an effect that's real or not, it's probably not a great paper. You need some type of graphic or something in front of your eyeballs that really show a difference between the two. An absolute difference. I think a huge thing he said at the beginning is, he says one of the biggest problems is statistics. There's a lot of the statistical manipulation and there's like trust in statistics. Meanwhile, the data in front of you doesn't seem to be telling you the same thing. And I think that that's really important, regardless if you're a statistician or not. And I think Richard admits that he himself is not a statistician, which that might be a feature rather than a bug for somebody who's trying to interpret these studies, because they don't have to look at, regression analyses and Bonferroni, which I don't think we even got into, but sort of corrects for the fact that they do all of these different tests. So you're supposed to change that p-value because, theoretically, if you do 5 tests, one of those is probably going to be due to so-called chance if your p-value is 0.05 or less.